The universe was supposed to be empty here. That's the part nobody likes to say out loud. When the James Webb Space Telescope turned its eye toward the oldest, darkest corner of creation, the corner that comes before stars, before galaxies, before light of any kind, it was looking into a place the textbooks called the Dark Ages. A void, a nursery with no babies in it yet. And then something looked back. That something has a name now. MOM-Z14, a galaxy sitting so far away that its light left home when the universe was only 280 million years old. To put a year on it, that light has been traveling toward us for more than 13.5 billion years, crossing 98% of all the time that has ever existed, just to land on a gold mirror floating 1 million miles from Earth. And here is the problem that has astronomers rattled. According to everything we thought we knew, MOM-Z14 should not be there. Not like this. Not this bright. Not this big. Not this far along. It's a galaxy that broke the rules of its own birth. This is the story of how a telescope went looking for almost nothing and found something that, by every model we had, shouldn't exist. To understand why this is so unsettling, you have to understand what the Dark Ages actually were and why anyone expected them to be dark in the first place. Picture the universe a few 100,000 years after the Big Bang. It's a fog, but not a cold one. It's a blinding fog of light, a thick soup of hydrogen and helium so dense with loose particles that a beam of light can't travel in a straight line before it slams into something and scatters. The whole universe glows. Then it cools. The particles settle, the soup clears, and that ancient glow fades away into the dark. And once it fades, there's nothing left to replace it. No stars, no galaxies. Nothing has ignited yet. For a long stretch of time, the entire universe is a cold, black ocean of gas with not a single point of light anywhere in it. Astronomers didn't pick the name Dark Ages to sound dramatic. They picked it because it was, as far as anyone could tell, literally true. And then, somewhere in that darkness, the first lights switch on. The first stars. The first clumps of gas heavy enough to collapse under their own weight and catch fire. The dawn. The very first sunrise in the history of everything. That moment, that flip from a dark universe to a lit one, is the single hardest thing in all of astronomy to actually see. It happened so long ago and so far away that the light has been stretched and dimmed almost to nothing by the time it reaches us. Catching it is the reason the James Webb Telescope exists. It helps to understand just how hard the previous generation tried and failed. For decades, the deepest eye we had on the early universe was the Hubble Space Telescope, with a mirror just under 8 feet across. Hubble was a marvel, but it had a ceiling. To see the earliest galaxies, you don't just need a bigger mirror, you need to see in infrared, because the expansion of the universe drags visible light down into infrared wavelengths over those enormous distances, and Hubble could only reach so far into that range. By the time Webb launched, with a gold mirror over 21 feet wide tuned specifically for infrared, Hubble had confirmed exactly one galaxy from the first 500 million years of cosmic history. One. A single bright object called GN-Z11 spotted back in 2016 that hinted these early galaxies might be more common and brighter than the theory allowed. But it was just a hint. A single data point at the edge of what was possible. Everything else out there was a candidate, a maybe, a smudge waiting for a better telescope to either confirm it or throw it out. So when astronomers finally aimed Webb at this region, they carried a prediction with them, a confident one, based on decades of work and the best computer models anyone had. The early universe was supposed to be a quiet place. The first galaxies were supposed to be small, dim, and rare. Faint little smudges, scattered thin, the kind of object you'd need to stare at for tens of hours just to confirm it was even real. Maybe a handful of them, hiding at the very edge of detection. That was the expectation. A few dim sparks in an enormous dark room. Keep that picture in your head. A few dim sparks. Because what Webb actually found turned that picture inside out. There's a useful way to feel how early all of this is. Take the entire history of the universe, all 13.5 billion years, and squeeze it down into a single calendar year. The Big Bang is the first second of January 1st. On that scale, the dinosaurs don't show up until late December. All of human history fits into the last few seconds before midnight on New Year's Eve. MOM Z14, this galaxy Webb found, is shining at us from around January 8th. The universe was barely a week into its first year. It had no business being interesting yet. In the spring of 2025, a team led by an astronomer named Rohan Naidu at MIT was combing through Webb's deep images, hunting for candidates. They were running a survey with a name that tells you exactly how skeptical they were going in. They called it Mirage, or Miracle. The whole point was to sort the distant smudges into two piles, the real galaxies and the tricks of light, dust, and noise, the mirages. And in this line of work, most of the time, you bet on the mirage. The universe loves to fool you, and a single fuzzy red dot at the limit of your instrument has 100 boring ways to lie to you. One object kept refusing to behave like a mirage. It sat in a patch of sky in the constellation Sextans, in a well-studied field called Cosmos, and on the first images, it was almost invisible. Below a certain wavelength of infrared light, it simply wasn't there at all. That sounds like a flaw. It's actually a fingerprint. When a galaxy is so far away that the expansion of the universe has stretched its light to extreme degrees, the short wavelengths get cut off completely, absorbed and erased by the hydrogen the light passed through on its long trip to us. The light just stops below a hard line, like a wall. Astronomers call it a Lyman break, and it's one of the most reliable distance signatures we have. The farther away the object, the farther up the spectrum that wall sits. This object's wall was sitting almost impossibly high, one of the sharpest, highest breaks anyone had ever seen. A photograph can suggest a distance like that. It can't prove it. So, in April of 2025, the team did the thing you do when you can't believe your own eyes. They pointed the telescope back and took a spectrum. A spectrum splits the incoming light into its individual colors, the way a prism splits sunlight into a rainbow. And buried inside those colors are lines, sharp, dark, and bright bands that act like a barcode for the object. That barcode tells you exactly how far the light has been stretched, and stretching means distance, and distance means age. There's no faking a spectrum. It's the difference between thinking you saw something and knowing. The number came back at 14.44. If you don't speak astronomer, that sounds like nothing. Here's what it means. Redshift is the measure of how much the universe has expanded since the light left its source. As space itself stretches, it pulls the light's waves longer, shifting them toward the red end of the spectrum, then past it into the infrared. The bigger the redshift number, the longer the light has been traveling, and the deeper into the past you're looking. A redshift of 14.44 means we are seeing MOM-Z14 as it was just 280 million years after the Big Bang. The previous record holder, another Webb discovery called JADES, sat at a redshift of 14.32, a galaxy from around 290 million years after the beginning. MOM-Z14 edged past it by roughly 10 million years. In a 13.5 billion year universe, 10 million years is a rounding error. But out at that frontier, every million years closer to the start is a million years deeper into territory we were never supposed to be able to reach. This was now, officially, the most distant object known to humanity. The oldest thing any human being has ever laid eyes on, and that alone would have been a headline. But the distance isn't what stunned everyone. The distance was almost the boring part. This is the part that broke the models. Remember the prediction? Dim, small, rare. MOM-Z14 is none of those things. It is luminous, brilliant, aggressively bright, the kind of bright that should take a galaxy hundreds of millions of years and many generations of stars to build up to. And it isn't a freak accident either. That same survey, scanning across a tiny sliver of sky, found that bright galaxies at this impossibly early age aren't rare at all. The number of them out there runs more than 100 times higher than the models predicted. Not 20% more, not double, over 100-fold. Imagine standing at the edge of a forest at night, certain it's empty, sweeping a single flashlight across the dark and catching 100 pairs of eyes shining back where you expected to find none. That's the feeling in the field right now. The early universe wasn't a quiet, half-empty room with a few faint candles flickering in the corner. It was already lit up, already roaring. The lights came on far earlier and far brighter than anyone thought was physically possible in the time the universe had to work with. One of the astronomers studying these objects, Peter van Dokkum, put the strangeness plainly. Webb wasn't expected to find galaxies this early, at least not at this stage of its mission. And the deeper problem was never about this one galaxy. It was that the early universe turned out to be crowded with brilliant galaxies that every model built before Webb insisted should not be there. The telescope didn't gently revise the theory. It drove a truck through it. So how do you build a galaxy this fast? That's the question that turns this from a record-breaking trivia fact into a genuine mystery. And the honest answer is that it isn't settled. Nobody is claiming it's solved. But the first suspect everyone reached for was a black hole. A lot of distant bright objects shine because they have a feeding supermassive black hole at their core. A monster pulling in gas and blasting out radiation as that gas spirals down the drain. An object like that can fake the brightness of an entire galaxy. So the team looked carefully at where the light was actually coming from. It wasn't a black hole. The glow wasn't coming from a feeding core. It was coming from stars. An enormous number of stars packed into a space about 50 times smaller across than our own Milky Way. We're talking about a galaxy, maybe a couple hundred light-years wide. A brilliant knot of stars crammed into a region so small it barely registers as having a size at all. Our Milky Way sprawls across 100,000 light-years. MOM-Z14 takes all that fire and crushes it down into a point near the dawn of time. It is the most distant galaxy ever imaged, and one of the most compact objects of its kind we've ever seen. All that light jammed into almost nothing. And then the spectrum showed something else. A chemistry that doesn't add up. Stars are factories. They forge heavy elements in their cores, then die and scatter those elements into space. And the next generation of stars gets built from the enriched ashes of the last. It's a slow process. It takes many cycles of stars being born, living, and dying to load a galaxy up with heavier elements. With only 280 million years on the clock, the universe simply hadn't had time to run many of those cycles. There shouldn't be much heavy material around yet. The early universe was supposed to be almost pure hydrogen and helium,
chemically clean, barely touched. Except MOM-Z14 is rich in nitrogen. Strangely rich. Its ratio of nitrogen to carbon comes in higher than the Sun's. And the Sun sits in a galaxy that has had more than 13 billion years to cook. A galaxy that's barely been alive for the blink of an eye somehow carries the chemical signature of something far more mature. That's the part that genuinely doesn't fit the timeline. As the Harvard astronomer Avi Loeb put it, the nitrogen we're seeing simply cannot be produced by normal stars in the time available. Normal stars can't do it. So something abnormal had to. This is where the story gets, honestly, a little eerie. Because that nitrogen-heavy chemistry isn't actually new to astronomers. We've seen it before, much closer to home, in some of the oldest objects in our own galaxy. Globular clusters. These are tight, ancient balls of hundreds of thousands of stars that orbit the Milky Way like fossils, leftovers from the universe's earliest days. They carry the same chemical fingerprint MOM-Z14 is showing us across 13.5 billion years, which raises a possibility that's hard to shake. When we look at MOM-Z14, we may be watching, live, the very process that built the oldest stars in our own galaxy. The fossils in our backyard, caught in the act of forming on the far side of the visible universe. Let that connection land for a second, because it's the kind of thing you'll want to tell someone tomorrow. The most ancient stars sitting in our own galactic neighborhood, and this impossible distant galaxy at the edge of everything, may be the same kind of object, glimpsed at the two opposite ends of time. But it still doesn't explain how the nitrogen got there. And the leading idea is also the most extreme one on the table.
Supermassive stars. Not the ordinary massive stars we already know about, the ones 10 or 20 times the mass of our Sun. These would be true monsters. Stars potentially thousands, even tens of thousands of times the mass of the Sun. Here's why the early universe, and only the early universe, could make them. Back then, the gas was nearly pure hydrogen and helium, with almost none of the heavier elements that let gas cool down and break apart into normal-sized stars. Gas that can't cool can't fragment. So instead of collapsing into thousands of ordinary stars, a single cloud could keep falling inward, piling up, building one colossal object. And in a dense, crowded early cluster, stars could have smashed directly into each other, runaway collisions snowballing into something enormous. A star so massive it would burn through its entire life in a geological instant and flood its surroundings with exactly the kind of nitrogen-rich material we're now seeing in MOM-Z14's light. These supermassive stars have lived on paper for years. Theorized, modeled, argued over in journals, never confirmed. MOM-Z14 might be the first place we're seeing their fingerprints written into real light from a real object. Might. The word matters, and the people doing this work are careful with it. This is the raw edge of what we understand, and the mystery is wide open. But the fingerprints are there, and they point somewhere strange. If you could somehow stand at the edge of MOM-Z14 and look around, you'd find yourself inside a universe that bears almost no resemblance to the one outside your window tonight. There's no familiar sky, no constellations, because there are barely any other galaxies to see, and the few that exist are blazing, violent infants. The whole place is hot, dense, and young, a furnace of star formation running at a rate that could never be sustained for long. You'd be standing inside the very first generation of the universe's lights, surrounded by stars so massive they'd make our sun look like a single spark off a campfire. And you would have no way home, because home, the Earth, the Sun, the Milky Way as we know it, won't exist for another 9 billion years. You'd be standing at the beginning, watching it begin, with everything you've ever known still waiting almost the entire age of the universe to be born. There's one more reading buried in the spectrum, and it points somewhere the models flatly forbid. When light from an object this ancient travels toward us, it has to pass through the early universe's other fog, a cold, dark sea of neutral hydrogen gas that filled all of space before the first generations of stars finished burning it away. That gas leaves a distinctive mark on the light, a kind of smear called a damping wing. And at a redshift of 14.44, virtually every model we have says space should still have been almost completely filled with that neutral gas, nearly 100% of it. The light should come through heavily smeared. MOM-Z14's light doesn't show a strong smear. The gas around it appears to have been partly cleared away already, at a moment when the textbooks say it had no business being clear yet. The signal is faint. It isn't strong enough to settle the question on its own, and the researchers are careful to call it tentative. But if it holds up, it means the process of the universe burning away its own fog, switching on and turning transparent, began earlier, in more places than anyone expected. One more clock running ahead of schedule. One more way this single galaxy keeps telling us our timeline is wrong. And this is what makes it bigger than one galaxy. MOM-Z14 isn't being treated as a one-off curiosity. It's being treated as the brightest member of a whole population we didn't know was there. The leading edge of a crowd. Webb keeps pushing the horizon back. And each time it does, the early universe turns out busier, brighter, and faster than the time before. The record for the most distant galaxy has now been broken again and again in just a few years. Each new champion lasting only until the next deep image comes in. We are not slowly confirming what we always believed. We are repeatedly discovering we were wrong, in the same direction, over and over. And in science, that pattern is usually the sign that something underneath the theory needs to change. The researchers who found it wrote that Webb is carrying us closer to the era of the very first stars, closer to the actual dawn. MOM-Z14 shines at us from 280 million years after the beginning. The first stars are thought to have ignited maybe 100 or so million years before that, which means we are now genuinely close to that line, close enough that you can almost feel it. A few more records, a few more impossible galaxies, and the telescope built to find the first light in the universe may actually find it. And it won't be working alone for long. The upcoming Nancy Grace Roman telescope is designed to sweep enormous patches of sky and flush out hundreds more of these early candidates for Webb to confirm one by one. The frontier that took decades to inch toward is about to open up all at once. For most of human history, the beginning of everything was a story, a theory, numbers in an equation, a thing that happened so long ago and so far away, it might as well have been a myth. And now there's a machine, floating in the cold 1,000,000 miles from here, methodically walking backward through time toward the first sunrise the universe ever had. Not imagining it, not modeling it, photographing it. MOM-Z14 is a single point of ancient light in a constellation most people will never glance at twice. But it's also a message. 13.5 billion years in the mailing. telling us that the universe woke up faster, burned brighter, and started its story far earlier than we ever dared to guess. We went looking for an empty room at the dawn of time. We found it already full of light, already on fire, already busy becoming everything that would one day become us. The Dark Ages got their name from us, from our certainty that nothing worth seeing could possibly be happening that early, in that much darkness, with that little time on the clock. MOM-Z14 is the universe quietly correcting the record. It turns out the lights were already on. We just didn't have the eyes to see them, until now. And the deeper we look, the more it seems the dark was never as empty as we needed it to be, and the universe was always in more of a hurry to exist than we ever imagined. And that's it for this video. Thanks for watching, and I'll see you in the next one.